So, like number 12, for example, what are you going to try to do here with this 729? It would be nice if you could change it to be a certain number to the third power. That way, the 1/3 and the third power cancel out, right? And you get your answer. So with the calculator, try to figure out what number to the third power gives you 729. So 9 to the third gives you 729. So what we know here is that 729, you could rewrite it as 9 to the third. But when you have a power to a power, when you have 9 to the third to the 1/3, the power to a power you multiply, and 3 times 1/3 cancels out. So your answer is just 9. Okay, and if you flip the paper over, you'll see that that's the correct answer. So all of these are pretty simple. With the calculator, it's pretty simple. How could you simplify this guy? Well, you don't really even have to think much. You could just type it all into your calculator. Once again, on your calculator, you're going to go open parenthesis, 1 divided by 32, close parenthesis, right? Hit the caret button so you could get to the exponent position. Open up another parenthesis so you could actually write the fraction 1 divided by 5, close parenthesis, hit equal, and you should get an answer. Let me do that right now on my calculator. On the calculator, I get 0.5, which means that the answer is 1/2, since we had a fraction to start with. Now, you could have done this without the calculator. You could have manipulated the base, which I enjoy doing. I don't know if you guys, the more you practice it, the more you enjoy it. Like, what do I mean by that? I know that 32, I could rewrite that as 2 times 2 times 2 times 2 times 2 times 2. No. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Yeah, I could rewrite the inside. I could rewrite it as 1 over 2 to the 5th power, and it's to the 1/5 power out here. And then I could take this, or I could, how about this? Instead of taking that, I could distribute the outside exponent to the inside. I could distribute the 1/5 power to the 1, which is still going to be 1, and I could distribute the 1/5 power down to the bottom. So I will now have 1 to the power of 1/5, which is still 1, so I'm not going to bother putting the power of 1/5 up there. But at the bottom, I have 2 to the 5th to the 1/5 power. And of course, the 5th and the 1/5 power to a power cancels out. So what do we have left? We have 1/2 left, which is the same answer, right? So you could use a calculator if you want, or if you want to start practicing manipulating the base, which is pretty fun, I think. But then again, I'm a math teacher. Go for it. Now, there is more to this section. There's also solving. Okay, so let's jump to the solving portion. This is where, how about this? Let's go over here. Now, what if I had 3 to a certain power is going to give me 9? What's my answer? 3 to a certain power gives me 9. What's the answer? The second power, right? Now, what we want to be able to do in this section is be able to, again, manipulate bases so that they're the same. So this is already a 3. The 9 could really change to 3 to the second power, which is the same thing as 9, correct? And over here we have 3 to the x. When you have the same base, we have a 3 here, we have a 3 there, you could ignore the bases, and this becomes your equation. X equals 2. Okay? So that's how we know that the answer is 2. So whenever you have x on the exponent and you want to solve, make those bases become the same. That way you could have a nice simple equation. So let's go back to the worksheet. Look at number 19. We have 2 to the x equals 512. Well, it would be nice if this said 2 to the x equals 2 to the something else, right? And whatever it is up here, like if it's a 7 or a 15, then your answer is going to be x equals 15 once you get it to be the same base. So with the calculator, let's think about 2 to what power gives me 512? Well, with the calculator, if you go 2 times 2 times 2, and you just keep going until you see 512. 2 times 2, that's 2, equals, times 2, that's 3, 4, 5, okay, that didn't work. 2 to the On the calculator, I just figured out that it's 2 to the 9th power. That gives me 512. Right? So that'd be a lot of multiplying by 2. So you could just start using the caret button. Like maybe on your calculator, go 2, caret, type in 5. See if that gives you 512. But it doesn't. 2, caret, if you go 2 caret 9, yeah, that's going to give you 512. All right, so what do we know for sure? That 512 could be rewritten as 2 to the 9th. And now that we have this equation with both bases being 2, now we could conclude that our answer is x equals 9. Because if you have the same base, you could ignore the base, and this is your equation, x equals 9. Does that make sense? Anybody? Number 20. You have 3 to the x. It would be nice if you could change the 3 to something. 3 to the something. Right? So with the calculator, start typing away. 3 to the, let me go 3 caret, let me go 8. Let's see what I get. No, that's too huge. It's 8? 3 caret 8. Oh no, it is 8. Lucky. All right, so we know that the answer, this could be manipulated to 3 to the 8th because 3 to the 8th really is 6,561. So now, what is our answer?
3.
X equals 8. Once you have the same base, you could ignore the base, and that'll be your answer. Whatever's left over, the exponent equaling the exponent. Make sense? Let's go to number 24. It would be nice if this guy could be rewritten as 4 to a certain power. I don't know if that's possible. Let's try it out. 4 to the 4th is 256. On the calculator, 4 to the 5th is 1024. There you go, 4 to the 5th. So my goal is to change that 1024 to a 4 to the 5th. Now, why is that my goal? Because once I have the same base, I could eliminate the bases, and my new equation will be the exponents equaling each other. So I really have, this is gone, I really have x minus 1 equals 5. So what is my final answer? X equals 6. And if you flip the paper over, you'll see that that's the correct answer. Jumping to 26. You have a base right here of 2. It'd be nice if we could change this to a base 2. In other words, 2 to what power gives us 2048? I have no idea. I'm going to jump to the calculator. And this is what I'm going to do on the calculator. 2, caret button. And then I'm going to start typing in numbers right there. And hopefully I'll get 2048 at some point. So 2 caret 9. That's 512. Not big enough. 2 caret 10. That's 10,024. 2 caret 11. That gives me 2048. So 2 caret 11 gives me 2048. So what does that mean? That 2048 could be rewritten as 2 to the 11th power. Yay? Bring down the equal sign, bring down the 2, bring down the power of 4x plus 3. And now that you have the same base, you could just eliminate the bases. They're gone. And your new equation becomes 4x plus 3 equals 11. Your new equation becomes this exponent equaling this exponent. There it is, 4x plus 3 equals 11. And now you're going to solve. You're going to subtract 3, subtract 3. You're going to end up with 4x equals 11 take away 3 is 8. And then you're going to divide both sides by 4. And you'll get your final answer, x equals 2. Thank you. Hope that makes sense. I'm done. It's Friday.